In past videos, we've already explained what is sets, what is relation. Now in coming few videos, we will talk about functions. Let's start with a definition of a function. If you have a set A and then you have a set B, right? And there are, let's say set A has 3 elements and set C has 5 elements. And there's a relation so there's a relation R from A to B such that each element of A has unique relation in set B, right? So two things. Every element of A has unique relation in set B. And such relations are called functions, right? So relation R from a set A to set B such that each element of set A has unique relation in set B. Right? Each element of set A has a unique relation to set B. This is called functions. This is represented as f A to B or A function to B, right? This is how the functions are defined. So it's basically two sets where set 1 or set A has a unique image in set B, then there's had to be a function from A to B, right? So in this case, there's few other definitions that we should remember. B is called codomain, right? The values which are mapped 1, 2, and 3 is called range, right? And A is called domain. Right? Let's take some examples to solve this and understand it better. Let's take an example. You have set A, which has 3 elements, A, B, C, and there is a mapping from A to Z and C to X to another set B. First of all, is this a function? Yep. So answer is no. And the reason is there is the element B in the set A which has no image in B, right? So B has no image in set B. Let's take another example. In an example, you have ABC. All of them have some image in B. Again, the question remains same. Is this a function? And again, the answer is no, because the element C has two images X and Y, right? So image for C is not unique. Image for C in set B is not unique, right? Let's take a third example. Again, the question remains same. Is this a function? So you have set A, which has three elements, 1, 2, 3, and each element has some image in set B, and all of that image is unique. So the answer is yes, right? So A belongs to A has unique image in B, and this is true for all A. The symbol is for all. So for all A, or all elements of A, so for all A which belongs to set A has unique image in set B. So hence this is a function, right? What if there were 4 more elements in this? Would that still be a function? And the answer remains yes, right? So it doesn't matter whether the elements in B does not have any corresponding relation from set A, right? As long as each element of set A has some unique relationship, so each element of set A has some unique relations of set B, then it is called a function. Now we talked about the range and the codomain. So what is the domain? One, two, and three. What is codomain? If it has an extra element of 7, 8, 9, is 2, 4, 6, 7, 8, 9. And what is range? It's 2, 4, and 6. Because 2, 4, and 6 is basically is an image in set A, or has a relationship from set A, right? So there's a domain, there's a codomain, and there's a range. Well, let's do another example, or maybe a couple of examples to see if this is clear. Let's take another example. So you have a set A, which is 1, 2, and 3, and there's a set B, which is A, B, C, and D, and we are talking about a Cartesian product A cross B. So is Cartesian product a function? right? So let's remember what is Cartesian product. So partition product means each element of A has a relationship with element of B, right? So if there is A and then there is B, then Cartesian product means one has a relationship with A, B, C and D. Similarly, 2 also have the relationship with A, B, C and D, and 3 also has a relationship with A, B, C and D, right? So again, the relationships of A to B is not unique, so this is not a function. What could have been the function? So if you have 1, 2, 3, A, B, C, D, E, A, B, C, D, and there was one relation. Right? You have 1 to A is the relations, 2 to B is the relation, and 3 to C is the relation. Then this is a function, right? So again, function is basically nothing but a subset of a Cartesian product. Right? So again, each element of A has a unique image in B. It's a function. In the next video, let's talk a bit more about domain, codomain, and range. We've already seen in this video what and how do you calculate these. Let's talk more about the 3 and do some questions which can help you find the domain, codomain, and range of a function. See you in the next lecture.